Hi. So I just showed you some electroscope demos, and I want to give a notes equivalent to that so that you can fill this out for your notes. So let me just share my screen for a second so we can see my little sort of like quasi whiteboard here. So here we can see this is the electroscope sheet that is available that I give you either in class or available on Google Classroom. So I wanted to go over a couple of things about the electroscope. First, we'll talk about structure, then we'll talk about function, and then we'll show each of the pieces about how it works. So here's the electroscope. Remind you there, this piece here is called the plate. The plate is the part that becomes the probe or where we are bringing charged objects nearby in order to sense things about the environment. The plate is electrically connected to this, and that is the stem. Okay. And this is the vane. The vane is the part that can rotate back or forth. So it can go from like straight up and down all the way to about horizontal. So I'm just kind of showing it in an individual space. So the vane is our piece that deflects back and forth. So remember, that's the appropriate phrasing to say. The vane either deflects or it doesn't deflect, or it goes back to undeflected. The deflect or undeflect is the right way to talk about the concept of the vane. So let's remember from what I said before, the plate, the stem, and the vane are all electrically connected. There's a little piece here of plastic that separates this metal bit from the metal circle so that electrons cannot travel from this electrical system into the circle system. Okay, so here we go. So the first thing we're going to look at here is if I bring a negative object nearby without touching the plate, right? So we saw, actually, before I do that, I apologize. Let's talk about the three purposes of an electroscope. The first is to detect charge. So to detect whether or not an object is charged at all. The second is to compare relative magnitude of charge. Remember, the electroscope is not going to quantify. We're not going to be able to say it's this many coulombs or this many elementary charges. It just could say this is more charged than that. We'll talk about how it does that. And then three is to find the flavor of an unknown charge. Okay, so those are the three purposes. So how does it do that? Well, to detect charge is going to be mostly through polarization. So now I'm going to bring a negative object close to the plate without touching it. That is going to polarize this electrical system. So the electrons in this, now by the way, this plate is exaggerated long. If you remember the one that I showed you in the video, the plate is only really small compared to this. So don't worry about this. But the charges or some of the electrons in the plate are going to be repelled by this, and you're going to have electrons that are going to move down from the plate down into the vane and the stem. That means that the plate takes on a temporary positive charge, whereas the vane and the stem take on a temporary negative charge. This causes the vane to deflect away from the stem. So this is polarized with a negative object, and this is what the charge distribution on the electroscope looks like. And so here the vane deflects in the presence of the negative charge temporarily, right? Because when I remove this charge, the electrons that went down into the vane and the stem are going to go back up to the plate so that the whole thing, remember, this is not a charging process. This is just what happens so that how the electroscope detects the negative charge. If I had a positively charged object brought close without touching, once again, that's going to polarize the system. But instead of electrons kind of being pushed away, electrons are going to be drawn up from the vane in the stem onto the plate, meaning the plate will have a temporary negative charge, and the vane and the stem will both have a positive charge, which is why, once again, the vane deflects temporarily. So this is what the electroscope looks like with polarized with a positive. Once again, the vane deflects in the presence of the positive charge temporarily. So it's kind of the same note there. And that's why Just by seeing a vein deflecting, I don't know whether the object that was brought near the plate is positive or negative. It's just merely detecting the presence of charge. We said in order to compare the magnitude that the angle that it achieves is one note or how quickly it deflects. So sort of two ways in order to compare relative magnitude. Okay, so let's go on to what it looks like when I actually do charging by conduction. So now the negative object touches the plate. So I have a transfer of electrons from here to here. Boom, 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 meaning every part of the object acquires a negative charge. So this is charged by conduction with a negative object. And that's why the scope ends up as entirely negative. And this will remain deflected. Because when I take the external charge away, there is still an excess of negative charges on this. So the stem or the vein is going to remain deflected away from the stem. And that's how you know that that object is charged. If, on the other hand, I put a positive and touch there, this thing has a lack of electrons. So it's going to pull electrons off of the electroscope, leaving the electroscope entirely net positive now. And once again, the vein will deflect away from the stem and will remain deflected. So it's charged by conduction with a positive. The scope is now positive and it's going to remain deflected, right? Until we neutralize it. And as we said, or I demonstrated in the other one, I can neutralize this by grounding it. All I would have to do is literally just touch the edge of this, and then the excess electrons would go into the earth. If I touch this, excess electrons would come off the earth onto this, leaving it neutral. Last, charging by induction. So if I bring my negative object close by, that would indeed polarize this, but we're not going to pay any attention to that because other things are about to happen. Then what I do is, so that's step one, is bring that close by. Step two is I then ground the electroscope, right? So now some of the negative charges that were in the plate, they want to get as far away from this thing as possible. So rather than go just down into here, because what you'll notice is during this process, the vein does deflect kind of temporarily before you ground it. So there is polarization happening, but that's not relevant. But some of the electrons will escape into the ground. And then what I want to do is I want to remove the ground. So the steps are really important there. Step one, bring the charged object close by. Step two, ground the scope. Step three, remove the ground. So if electrons have left the scope is left positive because it has a lack of electrons because some of the electrons were trapped off the scope into the ground. So that's what it looks like when we are charged by induction with a negative. The scope ends up positive and this remains deflected. All right. And then just for sake of completion, if I have a positive nearby, I can then ground the scope. Step two, this is going to draw electrons up because they're attracted to this, leaving excess electrons on here. And then before I remove this, really important, I get rid of the ground. And now those excess electrons are trapped on the scope. So this is what it looks like when charged by induction with a positive. The scope ends up negative and the electroscope remains deflected. Okay, so those are those pictures. The last thing I want to do is, whoa, that is a bee that just flew by my face. How to use the scope to determine the flavor of an unknown charge. So I just want to write down the steps that we saw in the demo. Okay, so step one is there's two flavors of the way to do this. I'll kind of go through both then. Charge, scope, a known charge. Sorry, I'm being attacked by a bee. Okay, either that's take a known negative, charge it by conduction with the negative so I know it's negative. Take a known negative, charge it by induction so I know the scope's positive. Take a known positive, charge it by conduction so I know it's positive. Take a known positive, charge it by induction so I know it's negative. Your choice. We just need to have a known charge on the scope. Okay, that therefore the scope is deflected. So scope has a permanently deflected vane. Okay. And the second thing you do is you bring a known near the plate. Or sorry, the bring the unknown. Bring the unknown near the plate. If the scope deflects more, the unknown is the same flavor as the known. And if it deflects less, so it's not about whether or not it deflects at all, because it's already deflected. It's about whether from there it deflects more or less. The unknown is opposite flavor. The other way you can do this is that we can charge the scope by conduction with the known. It's just easier to do it by conduct. Technically, you could do it by induction, but then why like invert the logic? Therefore, the scope and unknown are same flavor. And then you do the same test here, but now I'm bringing a known nearby. And if it deflects more, whatever known it deflects more with is the flavor, right? So if it deflects more when I bring the rubber nearby, I know the thing is negative, and it deflects more with the glass nearby, then I know it is positive. So if it deflects more with the rubber, it's negative. With the glass, it is positive. Okay. And those are the notes that go with the electroscope. So we'll be going through all of that in class. Make sure you're looking at this in conjunction uh, with the demos, because that really does help.